Alright, so apparently we're moving on to part 2 of our video here, where we were talking about number 7, but then got abruptly cut off because my iPad only allows 30 minutes of recording. So either way, we were on the second half, which of number 7, where we were saying that f, which is x squared, and g are going to be in a fraction of g over f, and in order to get that equation we were putting g, which was square root of 1 minus x squared, over f, which was x squared, and then if we drew an image, and that's where I was drawing it but then got cut off, we end up actually having an asymptote right here at 0. Of course, because dividing anything by 0 down here isn't going to work. And then actually this is cut off at the numbers -1, and then also with this asymptote at the number 1. So we are between there. And then, of course, if we plug in, for instance, the number 1, so 1 minus 1 squared would be 0, that's completely possible to exist, so we can include 1 and -1. And so when it comes to the domain of this image, we're looking at -1 included with x, but then stopping at 0, which is not included, and beginning at 0 and going to an inclusion of the number 1. So that's your domain of the second half of that one. Alright, then we'd move on to exercises 11 through 14 odds, and this is where we're starting to do the specific composite idea. Notice here we have f of g. Remember, it looks like fog, but it's f of g. And then having this 3 behind here is not multiplication. Okay, so remember that actually means that we are plugging in the 3 and not multiplying our result by 3. So in this case, for number 11, for instance, what I'm going to do is, if my f equation is this one and my g equation is this one, I'm actually trying to solve, let's use the colors, f of g of 3. And so as we did in the notes, what I'm going to do is evaluate this inner part here first. So to start, I'm going to take the g equation, which is x plus 1, and I'm going to plug in a 3 instead of the x, and get 4 out. And of course you can do this without showing every step. And then since g of 3 is equal to 4, then I'm going to take f of that 4, which used to be g of 3, and plug it in, and so now instead of 2x minus 3, it's not technically equal, I'm going to have 2, but then my x of 4, and then minus 3. So I'll have 8 minus 3, or 5. And so it turns out that the after all of that work, 5 is actually equal to f of g of 3. Alright, so a little less work in the second part here, g of f of -2. I'm going to find g of -2. And then that result I'm going to plug into f. So g of -2 becomes -2 plus 1. Oh, sorry, it's backwards of this. Because when you look at this, f is right next to the number, so that's the one we're going to do first, so sorry about that. So I'm going to do f of -2 first, and then take that result and plug it into g. I was wondering why it was the same format. Alright, So taking that into consideration, f is 2x minus 3, so we're going to do 2x minus 3, which will result in -4, -7. And so then we'll plug -7 in, and we'll get a g of -7, which is -7 plus 1. And so our g of f of -2 is going to be -6. Alright, then I'm going to go scooching over to the last page here and do number 13. So in number 13, we're given that f of x is x squared plus 4. And then there's a g of x, and that's going to be square root of x plus 1. And then again, we are trying to find, I believe, f of g of 3. And then we're going to do g of f of -2. Double check. Yeah. Alright, so if we put these together, remember that this is actually, in this first one, saying that we're going to take the f equation and put the g equation inside of it after we insert a 3 into that g equation. Same thing kind of goes for the next one. The outer function is going to be the g, and inside we're going to do f of the value 2. Alright, so to get us started in this first f of g of 3, if I do the g equation, that's the square root of x plus 1, but of course my x is actually going to be 3, and so that's going to result in the square root of 4, or 2. So I now know that that green part is actually going to be 2, so now I'm going to find f of 2, since I already evaluated the inside. And so f of 2 is going to be, where's my f equation, x squared plus 4, but our x is actually 2. And so 2 squared plus 4 gives us 4 plus 4, or 8. And so 8 is the result of f of g of 3. That's a bad looking 8, sorry. Okay, then the next one is trying to find g of f of -2, so we're going to start with finding f of -2, and the f equation is x squared plus 4, and so we're going to replace that x with a -2, which will result in a 4. Yes, -2 squared, even though you typed it into your calculator wrong, is actually -2 times -2, which is 4. And then 4 plus 4 is going to get us 8. And then we're going to find g of 8, because we evaluated the inside. And so now we're going to have the square root of x plus 1, but instead of an x, we're going to put in an 8. And so we end up with the square root of 9, or 3. And so 3 is our answer to this one here. Alright. Okay, so the next piece is number 15. We're supposed to find, again, the composite, but this is just our functions and not evaluated at a number, so this will only simplify versus become a digit or a constant. So they want you to find f of g of x. So if we give ourselves some color, we've got f of g of x. And so I'm going to take the time to write f, which is 3x plus 2. And then instead of the x, I'm going to insert the x minus 1 equation, which is g of x. Then, of course, it is always expected to simplify, so we're going to distribute our 3 and get 3x minus 3. And then we're going to simplify our numbers, and so we'll have 3x minus 1 as the result of f of g of x. Then I'm going to find g of f of x. And again, the reason that we do composites is so that we can actually find out if they are inverses of each other. So g is going to be x minus 1, but of course we're going to take away the x and plug in the f equation, which is 3x plus 2. Since there is no part outside of this parenthesis, we can just rewrite it as 3x plus 2 without parentheses, and then subtracting 1, which I'll stick to my colors. Whoops. And then the next one is going to then be 3x plus 1. Alright, so that's the other composite function. If both of these had equaled x, which they clearly do not, we would have inverses, but we don't. So, alright, then we have our last few problems here. Oh, close, not quite last few problems. In number 17, we must be using the same directions here. Yep, so we need to find f of g of x and g of f of x. So we will do that and, of course, simplify as much as possible. So we're going to find f of g of x. And so that means that I'm going to write the f equation and then insert, instead of the x, the g equation, which is square root of x plus 1. And so we'll be left with squaring a square root, so hopefully you can see that that's actually just going to cancel and become x plus 1, that we will be subtracting 2 from. And so x minus 1 is our f of g of x. But then we're going to do g of f of x. And so our g equation again was the square root of x plus 1, but no more x. We're going to put f inside, and f is x squared minus 2. Alright, so if we simplify, we're going to end up with still a square root, but we could put these two numbers together. And so we're going to end up with x squared, but then a minus 1. And then you may think, okay, let's go ahead and cancel our squared and our square root. But with this minus 1 here, that is actually not possible. So you can always check to see if whatever you're canceling ends up working by just plugging in, for instance, a 10 and seeing if you plug in a 10 and just subtract 1 from it, or if you plug in a 10 and square it, subtract 1 and square root, you're not going to get the same result. So you can always just plug in a number to double check. So this one, sadly, is just this as its answer. So not really anything too simplified. So, all right. Then in number 19, again, same idea. We're going to do f's and g's. So f of g of x. And so the f equation is x squared. And so we're going to erase the x and put the g equation, which is the square root of 1 minus x squared. And hopefully we know that squares and square roots end up canceling, and so we actually end up with just 1 minus x squared and nothing else to simplify. So that is our result of f of g of x. And then g of f of x. Write the outside equation first, so we're going to write square root of 1 minus x squared. And that x, I'm going to rewrite not the x squared, but the x itself as x squared. So that's going to be something we're going to expand. So taking a look at this, this is not a square and a square root, so instead we're taking x squared and then writing two of them. So this is technically x squared times x squared, and so that's x to the fourth. So we're going to end up with 1 minus x to the fourth. And then again, some of you are thinking that you could reduce that with that square root, but since there is that subtraction happening, we can't. And so that's just the end. All right. Moving on, in exercises 23 through 30, we need to find f and g so that the functions can be described as g being inside of f. So again, this statement here is g inside of f. Sorry, and you can see that there may be more than one possible decomposition, so this is just the way that, for instance, I am seeing it. And so, especially since we have this square root here, I'm going to say that the outside equation, since that's on the outside, of f is going to be the square root of x, or square root of whatever we have. And then since g is on the inside, it's going to be whatever is sitting in the inside of that square root. So x squared minus 5x. And of course, if you want to know if what you did worked, you would then go back up to what we did, for instance, up here, and try that operation with what you've just created. The next piece that I'm going to do here, you can definitely see these absolute values are on the outside. So I'm just going to say that the outside, or the outermost equation, is something being taken an absolute value of. And then the g I'm going to use as 3x minus 2. And again, you can be as creative as you would like with those, but I just picked the outermost thing, and that's the outer equation. All right, we're going to do the same thing here in number 27. So again, the outermost equation, as you can see here, is an x to the fifth, or something being raised to the fifth. But with that outer equation, you also have a plus 2. So I'm going to say that my outer equation is x, or this quantity, to the power of 5, and then plus 2, which leaves for the inside equation just x minus 3. All right, and then these last few here, we need to confirm that f and g are inverses. So this is what I was talking about in our previous example, and so all we need to do is find out if f of g of x equals x. Okay, because if it equals x once we do our composites, then we're going to have inverses. So let's go ahead and do f of g of x. And when you simplify, you're trying to find out if you can get to x. So the equation for f of x is 3x minus 2, but we take away the x and fill it in with this giant fraction here of x plus 2 divided by 3. Hopefully you can see that the 3 and the 3 are going to cancel, because if you take this quantity and divide it by 3, but then also multiply by 3, you're going to just be left with that quantity. So we do instead have x plus 2, and then to that we'd be subtracting 2. And then, of course, those two cancels, and so we have x. So we have just determined that f of g of x equals x, but remember that we also need to determine that g of f of x equals x as well. So we're going to write g of x, since that's on the outer of solving this one. And so g of f of x is an x that we're adding 2 to and dividing by 3. And that x is going to become f of x, which is 3x minus 2. Since nothing's really happening with that set of parentheses, we can just rewrite the numerator as 3x minus 2 plus 2, and all of that divided by 3. The numerator then, the plus 2 and the minus 2 can cancel, and so we'll be left with 3x divided by 3, which of course will cancel the 3's, and we'll have x, which means that g of f of x equals x as well. And so because they both equal x, f and g are inverses. All right. Then we're given the next one here, number 29, and so again we're just going to find out what f is and g is when we composite, and hopefully they're both x. If they're not, then we have non-inverse functions, but if they are, then we have inverse functions. So it's not really good or bad, it's just inverse or not. So if we have our f equation, it's x to the power of 3 plus 1. That's a bad plus sign. And so the x is going to be replaced with, where's my g, the cube root of x minus 1. So without going too far into it, hopefully you can see that a cube and a cube root would cancel, just like a square and a square root would cancel. And so we'll just be left with the x minus 1 that we will add 1 to. And so that first equation does in fact equal x, so f of g of x so far equals x. And so then we'll do the next one. And so the next one is g of f of x. And so the g equation is this cube root idea of x minus 1. And then instead of an x, we're going to put in the f equation, which is x cubed plus 1. Hopefully, since we input that and it doesn't actually do anything to have those parentheses there, we still have the cube root, but now you can see that x cubed plus 1 will be subtracting 1, which will cancel. And then we'll be left with the cube root of an x cubed, and of course the cube root and the cube will cancel, and so we're left with x as well for the other statement of g of f of x. And so we can say that since they both equal x, f and g are inverses. Now I just want to be clear that if they both equaled x squared, that's lovely, but they're not inverses. Okay, so it does only get to equal x, and that's it. So if they're the same, fine, but if they have to be the exact of x, not anything else. All right, so then our next piece here, again, finding composites. We have the f of g of x, which leaves us with the f equation that we replace each of the x's with the g equation. This is when, oh Lord, there's a lot of things that could happen with this one. So the first thing I'm going to do in this numerator is find a common denominator. Okay, because I can't add 1 to something that's a fraction without turning that 1 into a fraction. So I'm going to rewrite that number 1 as x minus 1 over x minus 1. Because hopefully we can all agree that x minus 1 over x minus 1, no matter what the x's are, would be the number 1, which is what we just had. Then I'm going to go ahead and add, since they have a common denominator, I get to add the numerators together. And so this is now going to equal 1 plus x minus 1, and all of that will be over the common denominator of x minus 1. And then, of course, over what we still had, which was 1 over x minus 1. Then we have to realize that dividing fractions means that you're going to multiply by the reciprocal. Okay, so this one clearly is a challenge problem, all right? And so do not take offense if you can't get through this one. It's just something that hopefully you can at least watch and follow. So this next piece says that we're going to multiply by the reciprocal, so remember that means flip. So we're going to rewrite the first piece, which is just 1 plus x minus 1 over x minus 1. And to that we're going to multiply, instead of divide, by the flip, so x minus 1 over 1. Before we go any further, I'm just going to take a minute to say that 1 plus x minus 1 is not going to necessarily make any difference. And so we actually have x over x minus 1 times x minus 1 over 1. Hopefully from here you can see that these groupings are the same, and so they would cancel. And so technically we are ridiculously left at x. So f of g of x is x. So now we need to do g of f of x, because otherwise we won't know. So let's get my colors right. G is blue. And we are on problem number 31. And so in order to set this up, I'm going to put the outside equation of the blue one, which is g, and g is 1 over x minus 1. And then instead of the x, I'm going to put the f of x equation, which is x plus 1 over x. Alright, so just as we did in the previous one, I'm going to rewrite this equation so that that number 1 on the bottom is actually a form of 1 so that it can be combined with the equation next to it. So I want this denominator of x to be a denominator in this variable of 1, or constant. So x plus 1 over x is now actually going to be subtracted by x over x, because that is, again, a form of 1. From there, I'm going to actually take the time to subtract them. So I'm going to have 1 over a numerator of x plus 1, but then minus x, because I'm combining the numerators, and then putting them over the common denominator of x. Alright, then we get to do some fanciness, because notice that this 1 on top, I'm actually going to take the time to write that 1 as 1 over 1 divided by this denominator of x plus 1 minus x over x. Before I do that, I'm actually going to take the step back here and realize that x minus x leaves us with a 1 over x. And so notice that I am going to have a fraction over a fraction, and so in order to get rid of that, I'm actually going to change that to a fraction times a fraction, but in order to do that, I'm going to have to flip this fraction. So again, the only reason that I can change this division into multiplication is because I flipped it, and so now it's x over 1. If you multiply across 1 times x and 1 times 1, you get x, and oh my gosh, after all of that work, we now know that g and f are inverses. And again, we know that they are inverses because both of them, after all of that fractioning, actually both equal x. Alright, so that was the last problem, and again, remember that that one was a challenge, so if that didn't work out so well for you, that is okay. You can pretend that you skipped it. All right, that's that.